A very good morning to all of you. Today we will discuss about an glycogen metabolism. In this glycogen metabolism, we will discuss about the glycogenesis, glycogenolysis, regulation of glycogen metabolism, and disorders in short. So we will discuss these four things in glycogen metabolism. The glycogenesis means synthesis of glycogen from glucose. Glycogenolysis means dissolution of glycogen into glucose. Regulation mainly by the two hormone, that is insulin, glucagon, by dephosphorylation and phosphorylation of key enzymes which regulate the pathway of glycogenesis and glycogenolysis. And we'll discuss about the 7 important disorders in glycogen metabolism, that is glycogen storage disorders. Now coming to the glycogenesis, as all of you know that glycogen, it is a homopolymer of glucose composed of alpha 1,4 glycosidic linkage in a linear molecule and alpha 1,6 at the branching point. This branching makes the molecule globular, compact and less space consuming. Now coming to the glycogenesis, by definition, glycogenesis means synthesis of glycogen from the glucose. The site for glycogenesis is the cytosol. It is mainly in the liver and muscle. As there is synthesis of glycogen, for the synthesis of glycogen, the glucose should be available. So in well-fed state, there is synthesis of glycogen from the glucose, that is known as glycogenesis. We will discuss the steps in the glycogenesis. This is a glucose molecule. From this glucose molecule, there is formation of glucose 6-phosphate. As it is in the well-fed state, the important enzyme is glucokinase. Then with the help of mutase, this glucose 6-phosphate is converted into glucose 1-phosphate. And with the help of UTP molecule, this glucose 1-phosphate is converted into UDP glucose. So up to this step, this is known as activation of glucose or synthesis of UDP glucose molecule. So this is the first step, that is, it is a activation of glucose. Now for the synthesis of glycogen, the glycogen primer is required. Glycogen primer is a short glycogen molecule or pre-existing glycogen molecule to which there is addition of glucose, or if there is in the absence of glycogen primer, there is one substance that is known as glycogenin. Glycogenin. This is a protein with oligosaccharide side chain. The 7 glucose residues are attached to the glycogenin. In the absence of glycogen primer, glycogenin can initiate the glycogen synthesis. So the second step in the glycogenesis is the initiation of glycogen synthesis. This is the first, this is the second, initiation of glycogen synthesis. In the initiation of glycogen synthesis, with the help of glycogen synthase, this is glycogenin. With the help of glycogen synthase, this UDP glucose gives the glucose molecule to the glycogen and elongates the glycogen primer. In the each step, there is addition of one glucose molecule which is carried by the UDP. So there is lengthening of the glucose molecule in the successive step. So it will becomes glycogenin or glycogen primer. In the successive step, there is addition of glucose molecule, and near about 11 to 12 glucose molecules get attached to this glycogenin by the action of glycogen synthase. This is the key enzyme in the glycogen synthesis, glycogen synthase. Now when the glucose chain is long, up to 11 to 12 glucose residues, then the 6 to 8 glucose molecules from this chain, 6 to 8 glucose molecules from this chain get detached from this linear glycogen molecule and it get attached to the another site. In the next step, this is glycogenin or glycogen primer. There is detachment of this short oligosaccharide chain or 6 to 8 glucose residues from this linear molecule to the another side, and there is formation of this branch point. By the action of branching enzyme. So the first step is the activation of glucose, means the formation of UDP glucose. Then initiation of glycogen synthesis. Third step is the elongation. Elongation means there is addition of glucose to the growing chain. Then after the elongation, the fourth is the branching with the help of branching enzyme. Then this process of elongation and branching continues till the formation of glycogen molecule. So this will continue till the formation of glycogen molecule. So the next step is the elongation and branching, and there is formation of glycogen. So this is glycogen synthesis. I repeat, there is glucose which is converted into glucose 6-phosphate, glucose 1-phosphate. There is formation of UDP glucose, means activation of glucose molecule. This UDP carries the glucose molecule. These glucose molecules added successively to the glycogen primer. If there is no glycogen primer, then it is added to the glycogenin. Then after the elongation of 11 to 12 glucose residues to the glycogenin, there is transfer of these 6 to 8 glucose molecules from this linear molecule to the branching point. There is creation of branching point here, means there is creation of alpha 1,6 glycosidic linkage here by the branching enzyme. Then this process of elongation and branching continues till the formation of glycogen. So the key enzyme in this pathway is the glycogen synthase. The important point to remember here, this glycogen synthase, it is active in dephosphorylated state. Okay, while glycogen phosphorylase, it is active in phosphorylated state. Now we will discuss about the glycogenolysis. The site for glycogenolysis, it is the cytosol, and it is in the liver and muscle. The difference is that in the liver, the end product of glycogenolysis is the glucose, and this liver glycogenolysis will provide the glucose molecule in between the meals. After the 12 to 18 hours of the meal, this glycogen store get depleted. Then we utilize the body will form the glucose by the gluconeogenesis after the 12 to 18 hours of fasting. Now coming to the glycogenolysis. Lysis means dissolution. Glycogenolysis means there is formation of glucose from the glycogen. The site is cytosol, mainly in the liver and muscle. Here the end product in the liver, it is glucose, while in muscle it is glucose 6-phosphate. Because in muscle there is absence of glucose 6-phosphatase. This enzyme, it is absent in the muscle. That's why the end product is glucose 6-phosphate, which enters the glycolysis, and there is synthesis of pyruvate and lactate in the muscle. Now coming to the glycogenolysis. So suppose this one is the glycogen molecule. This is glycogenin or glycogen primer. These are the glucose molecules attached. This is the linear chain. This is the branch point. The here linkage is alpha 1,6 glycosidic linkage, and here in all linear chain it is alpha 1,4 glycosidic linkage. This is a glycogen molecule. The main key enzyme in glycogenolysis, it is a glycogen phosphorylase. The main action of glycogen phosphorylase is to remove the glucose molecule successively from the glycogen. And the PLP is required, pyridoxal phosphate, it is required as a coenzyme for glycogen phosphorylase. With the action of glycogen phosphorylase, there is removal of glucose molecule one by one until the formation of limit dextrin. Limit dextrin means there is 4 glucose residues on either side. This is glycogenine. There is 4 glucose residues on either side of glucose molecule, that is known as limit dextrin formation. As it is nearer to the alpha-1,6 glycosidic linkage, the action of glycogen phosphorylase stops. So what is the action of glycogen phosphorylase? Glycogen phosphorylase removes the glucose molecule one by one in the form of glucose 1-phosphate. It removes the glucose molecule in the form of glucose 1-phosphate. This glucose 1-phosphate, it is converted into glucose 6-phosphate and ultimately the glucose molecule until the formation of limit dextrin. Then there is role of debranching enzyme. It is a bifunctional enzyme. It has two important functions. The first important function of this debranching enzyme is, first is the transferase activity. Due to the transferase activity of debranching enzyme, this debranching enzyme transfers this trisaccharide unit from branching point to the linear molecule. So there is transfer of these three from here to this linear chain. Now this point is free for the action of glucosidase, and glucosidase will act on this. So this is the glycogenine. Now this is a linear chain. Here is the branching point. This is the alpha-1,6 glycosidic linkage. This one is the trisaccharide unit which get transferred from this branching point to the linear chain. Now by the action of glucosidase, alpha-1,6 glucosidase, this will remove the glucose molecule, and here is the free glucose get liberated by the action of glucosidase. So it is a bifunctional enzyme. Debranching enzyme is a bifunctional enzyme. It has transferase activity. Transfer the trisaccharide unit from the branching point to the linear chain. Then glucosidase activity will remove the alpha-1,6 glycosidic linkage, and there is formation of linear glycogen molecule. This is glycogenine. So there is formation of linear glycogen molecule, linear glycogen. Then as it is a linear molecule, there is again action of glycogen phosphorylase, which removes the glucose in the form of glucose 1-phosphate. One by one there is removal of glucose molecule in the form of glucose 1-phosphate. Then this glucose 1-phosphate, by the mutase, it is converted into glucose 6-phosphate, which is converted into the glucose in the liver. While in muscle, this glucose 6-phosphate undergoes the different fate, or it undergoes the glycolysis for the production of energy. So this is the glycogenolysis. The steps in the glycogenolysis are, the first one is the action of glycogen phosphorylase until the formation of limit dextrin. Then there is action of debranching enzyme. Debranching enzyme removes the trisaccharide unit from this branching point and attached to the linear molecule. by the transferase activity. Then by the glucosidase activity, it removes the alpha-1 6, cleave the alpha-1 6 bond and removes the free glucose here. There is formation of linear glycogen molecule by the action of glycogen phosphorylase. Again, there is removal of 1 by 1 glucose molecule in the form of glucose 1 phosphate, which get converted into glucose 6 phosphate, and ultimately there is glucose formation. So this is all about glycogenolysis.